Here is my completed data page. I have speeds, the coefficient of friction values that I wrote down from the simulation, the distance along the incline, height of the incline, and the angle for all 4 different runs. Once the data table is filled out from doing the simulations according to the procedure, then the rest of the work is doing the calculations. You're going to calculate the change of energy. You're going to calculate the work. These calculations are to be independent of each other. The purpose of the lab is to show that the change in energy is equal to the work done. Work is force times distance along the incline. Independent of that, you are going to find the change in energy. You have all gravitational potential energy at the top of the incline. You have all kinetic energy at the bottom of the incline. The change in energy will be the difference between the two, the total energy final minus the total energy initial. To compare the change in energy to the work that was done, use the percentage difference. The percentage difference is used when you have 2 items to compare, neither one of which is an accepted value. When we have an accepted value to compare to an experimental result, we use the percent error. The percentage difference equation looks like percentage difference is equal to the absolute value of result 1 minus result 2 divided by the average of result 1 and result 2, all multiplied by 100%. The closer the 2 values are to each other, the closer the percentage difference will be to 0. Excel is an excellent resource for doing repetitive calculations, and repetitive calculations is what will be done for this lab. Your data will be put through calculations of kinetic energy, gravitational potential energy, work, and percentage differences. In all, there may approach 100 different calculations. These can be done by hand, or you can take the time to fill out an Excel spreadsheet as I have done here. Here is my example for using Excel. I have my masses for all 4 data tables in kilograms, the coefficient of friction values, the angles, and a separate column for the angles in radians, which is needed to do calculations in Excel. The distance along the incline in meters, the height in meters, and the speed in meters per second. After that are the calculations. There's a column for calculating the kinetic energy in joules, one for calculating the gravitational potential energy, a column that is the difference between each of them. Following that is a column where the work is calculated, force of friction multiplied by distance down the incline. Remember that the force of friction is related to the normal force, so you may need to do a free body diagram to find the friction force in terms of a component of the weight. The last column is for the percentage difference. I have an extra column with the difference between the energy change column and the work column, but you do not really need this unless you just want to be cautious. As I said, this is a calculations-intensive data analysis. You will want to explicitly demonstrate with your data one example of the kinetic energy equation, one example of the gravitational potential energy equation, one example of the work equation, and one example of the percentage difference equation. If you choose to do all 100 or so calculations by hand, make a table of all subsequent calculations. Do not include multiple pages of individual calculations with your data. And if you use Excel, once you have done a calculation by hand, put the equation referencing your data into the correct column, and you should see your hand-generated calculation validated. Then you know that you can copy that equation down the column, and for all numbers generated should be correct if the data going into the equation is correct. What you will submit. In addition to answering the questions and completing the data tables, you will have one worked out example of the kinetic energy equation with a line of your data, the gravitational potential energy from a line of the data, the work equation from the same line of data, and a percent difference calculation from that same line of data. Those results should be the first line of your completed calculations column, whether you do them by hand or using Excel. Following those worked out examples should be those calculated tables. If you use Excel, it would be only the columns that list the kinetic energy, the gravitational potential energy, the difference between the two, the work column, and the percentage difference column. Your other data should be in the data table, so there should be no need to include those columns from Excel.